Now I'll discuss with you about the change of order. How do you solve the problem on the change of order? See, I told you earlier also this is very important. You get a question on the change of order. All right. Sometimes change of order, you are asked to change the order. Sometimes you are given an integral and you have to evaluate an integral. You won't be able to evaluate the integral in the given order. So there you have to change the order in order to evaluate the integral. See, I write both the order and the format of the limits. See, sometimes when your definite integral is of this format. See, f xy dx dy. It means I have to evaluate it first with respect to x and then with respect to y. So the limits will be of, say, f1y to x equals to f2y. Then once we integrate it with respect to x, we integrate it with respect to x, keeping y constant, and then we put the limit of x. Then whole thing becomes a function of x, and so whole thing becomes a function of y, and then that is integrated with respect to y. So the limits becomes y equal to c to y equal to d. This is one way of doing this integral. Other way, this is one order, first with respect to x and then with respect to y. The other way is you integrate it first with respect to y. You integrate it first with respect to y, and then you put the limit of y. When you integrate it with respect to integrate with respect to y, you keep x constant, and then you have to put the limit of y in terms of x. See, g1x to y equal to g2x, and whole thing become a function of x, and then you put the limit x equal to a to x equal to b. So regardless of the order in which you integrate, your answer is going to remain same. But sometimes it is easier to integrate in one order compared to the other. Sometimes you are given an integral which will be difficult to integrate, which you won't be able to integrate even in a given order. Then you have to change the order. We can see an example. Suppose I give you a question. Suppose I ask you, you integrate this question. You do this integral e to the power minus y dy dx from y is varying from x to infinity and x is varying from 0 to infinity. Say this integration. See, you can't integrate it in a given order. E to the power minus y by e to the power minus y upon y dy. I can't integrate this. This won't be integrated. I can't integrate this, though this is integrable. But I can't integrate this. We cannot integrate this in the given order. I can't have this integral, right? So you won't be able to integrate it. But we can easily integrate it by changing the order. We can easily integrate it by changing the order. If you change the order, you will have, this will be written as e to the power minus y upon y dx dy, and then when you change the order, the limits over here changes. I'll tell you the method how to get the limit of this integral, but right now I am putting it right. I will discuss the way how we can get the limit after changing the order. So this limit comes out to be 0 to y and then from x to infinity. I'll tell you the way how I get this. This is a topic where I'll tell you the way how I get this. Alright, so this equals to, this become equals to, so if I integrate it, now this is integrable. See, I can integrate with respect to x, I'll keep y constant, I'll get x to infinity, and then I integrate with respect to x, these are all constant. So integral of dx is going to be x, and then I have to put the limit of x 0 to y dy. So this comes to be x to infinity e to the power minus, sorry, this is not x to infinity, this is this is not x to infinity. Sorry, I am very sorry, this is not x to infinity, this is 0 to infinity. This is 0 to infinity, right? I am very sorry, this is 0 to infinity. I can't have x to infinity because, see, ultimately this has to be a constant, right? This is e to the power minus y, this also becomes y. So this is e to the power minus y dy, which can be integrated to this. So I get it as 1. So you see, this is very difficult to, I can't integrate this. But after changing the order, the integration becomes very easy, right? So in these kind of question, the change of order is compulsory. You will be asked to evaluate this integral. They won't ask you to change the order, they will ask you to evaluate this integral. Then you have to yourself see that whether I can integrate it in given order or not. And moreover, if it is a question on double integration, if they give you this question and you are able to evaluate in the given order, then this is not a question of double integration, it's just a question of question of definite integral two times. This is repeated integral. If it does not involve a change of order, the question becomes very simple. There is nothing in double integration, then you have to integrate it two times, right? That is a kind of question on repeated integrals. That won't be a good question on double integration. So even when you are given a question on double integration, in most of the cases it will always involve a change of order, or it will involve the transformation of variable. If it is not, then it is not a good question on double integration. It is just a question of repeated integral, where you have to do the definite integral two times. You do first this and then this, right? So I'll take one question and I'll discuss with you how to change the order. Suppose we have to solve this integral. We have to change the order of integration 0 to a by 2 x square by a x minus x square by a fxy dy dx. Suppose we have to solve this. Here we have to change the order. You are given an order. First you are integrating with respect to y, and then you are integrating with respect to x. So you are given the limit of y and you are then given the limit of x. So this integral is given in, if I compare, this is of the form fxy dy dx, where the limit of y is of the form y equal to say f1x, y equal to f2x, and x equals to a, x equals to b. See, the first thing you do in the change of order is you first plot the domain of integration. You first plot the region of integration. For plotting the region of integration, you first have to find the bounding curves. What are the bounding curves of the domain of integration? Like you have to first get the domain of integration. So first thing is you have to get the domain of integration, right? First thing you have to do is you have to get the domain of integration. You have to get the domain of integration. And what is the bounding curve of the domain of integration? That you get by comparing this. If you compare this, this is y equal to f1x, this is x square by a. So the first bounding curve is y equal to x square by a. This is one bounding curve. The second bounding curve is y equal to f2x, that is y equals to x minus x square by a. Y is varying from y equal to x square by a to y equal to x minus x square by a. The third is x equal to 0, and the fourth is x equals to a by 2. So these are the set of bounding curves. So we have to plot it. We have to first plot it. So while plotting, see, you can recognize these curves. First let us recognize these curves. What is these curves? What these curves are? See, this curve, the equation of this curve is linear in x, linear in y, and quadratic in x. So whenever you are given a equation which is linear in x and quadratic in y, or linear in y and quadratic in x, you can have a doubt without so you have a curve which is linear in one variable, quadratic in another variable. This will be a parabola. Similarly, this is also a parabola, right? This one, second is also a parabola. So this is a parabola. Similarly, this is also a parabola, and these are the two straight lines. So I'll briefly discuss how to plot this parabola. Alright, see, if I are given, this is the coordinate system x and y. See, the general equation of parabola can be y equal y minus beta whole square into 4a x minus alpha. So alpha and beta are the vertex. We call it vertex, right? This is beta. This is beta. right? It doesn't look like beta, so write it once again. This is beta. So your parabola is like this. This is the parabola, right? This is a parabola with the axis parallel to x-axis and alpha beta as the vertex. If A is positive, it will be this parabola, and if A is negative, then the parabola will be like this. This will be the parabola if A is negative. Alright. So if you are given a equation which is quadratic in y and linear in x, you try to express that equation, you try to reduce that equation in this format so that you can get the vertex, right? You can get the vertex and you can get an idea by this seeing the sign of this 4a, you can get an idea whether this will be like this or like this. The other equation can be in the form x minus alpha whole square 4a y minus beta. In this case, the parabola will be like, see, alpha and beta is the vertex, and the parabola will be like this. If your A is positive, see, alpha and beta, and your parabola will be having concavity downward if your A is negative. So you remember this. When you are given the equation in the form of, say, it is quadratic in x and linear in y, you try to reduce it to this form. So this is such an equation. So let me plot these two. Let me plot these two parabola. I'll rub this, right? Let me rub all these things. So I have to, the first task is we have to plot the domain of integration. We have to get the domain of integration. How we will get it? We have to plot these curves. So let me plot these curves, right? So I'll plot these curves. I'm deleting all this. So let me plot all this curve so that I can get the domain of integration, right? So these are the bounding curves, right? These are the bounding curves. So first of all, I'll plot this x square equals to ay. So if this is x, this is y, then this can be plotted like this is like this. This is your plot, right? Now I have to write this in a standard form. I can write this as x square minus ax equals to minus ay. So let me write it in this form: x minus alpha whole square 4a y minus beta. So this will be x square minus ax plus a square by 4 ay plus a square by 4, right? So this is x minus a by 2 whole square and minus a y minus a by 4. So what is the vertex? Vertex is a by 2 a by 4. Let me assume a to be positive. Nothing is written, so by default let me take it as positive. So a by 2 and a by 4 is the vertex. A by 2 and a by 4 is the vertex. So see, you always apply some common sense and you try to check whether this a by 2 or a by 4 is lying on this curve or not. So if I check it, I'll get, we see a by 2 a by 4, this particular coordinate satisfy the first equation, x square equal to ay. So I think this will be lying on this curve, the first curve, a by 2 a by 4. This you have to apply, you have to apply your mind, right? So the curve can be plotted like this. I can plot the curve like this. I can plot this curve, alright? So a by 2 and a by 4 is the point of intersection which lies on the first parabola also. Now I have to plot x equal to 0. So x equal to 0 is this line, y-axis, and x equal to a by 2 will be a line passing through this, right? Let me draw it once again. This is a line passing through the point of intersection. This is x equals to a by 2. This is x equals to a upon 2. So what is the region bounded by these two parabolas and these two lines? Obviously it is going to be this region. So this is the domain of your integration. This is the domain of your integration. So the first thing we have done, we have plotted, we have got the domain of integration, and after this it will be very easy to get the limit after changing the order. See, you are given the integral in dy dx form, right? Now I have to put it in dx dy form, right? I have to put it in dx dy. I have to put in this order, right? Now for this we must get the limit of x over here. See, the format of the limit is, see, the format of the integral f dx dy, where x is equal to f1y, x is, the limit is like this, x equal to f1y to f2y, and y equal to c to y equal to d. We have to write in this format. So you see, just remember the format, right? Just remember the format. So we have to get the limit of x. So for getting, if you want to find the limit of x, you do one thing, you just draw an arrow in the direction of increasing x and see where does it intersect. See where does it intersect. It is intersecting the curve over here, right? So this is the curve which the arrow intersect. So put the equation of this curve in this format, x equal to f1y. Put the curve which it intersect first, put the equation of this curve in the form, in this form, as a x equals to x as an explicit function of y. The equation of this curve, if you want to get the limit of x, lower limit of x, this arrow intersect first this curve. So this equation of curve, the equation of this curve has to be written as x as an explicit function of x and y. See, your equation is over here, your equation is y equal to x minus x square by a. So I can write this as x square minus ax plus ay equal to 0. And if I want to write in this format, I'll get x equals to plus a plus minus, this will be a square minus, let me see, yes, so this is a square minus 4ay upon 2. So what I get is a by 2 plus minus a square minus 4ay upon 2. Alright, so I get two values. X is a by 2 plus minus. Why two values? Because see, this arrow intersect the curve at two places. See, here and here. But we are concerned about this point, right? We are concerned about this point. You see, this arrow is, sorry, this is not the point. It is intersecting at this point and this point, right? You are getting, this is not a, this is a point only for parabola. So the arrow intersect at 2 points. That's why you are getting the two values, a by 2 plus and a by 2 minus. This is a by 2. This is a by 2 plus and this is a by 2 minus. Forget this. This is the different curve, right? So we are getting two values of x because the arrow intersect first over here and then over here. See, this distance is a by 2. So this will be, this point will correspond to a by 2 plus a square minus 4a upon 2. This point is before a by 2, right? Before this line. This point is on the left of this line. This is a by 2. The distance of this line from y-axis is a by 2 and this point is at a smaller distance. So this will be a by 2 minus a square minus 4a by 2. So I write it here, x equals to a by 2 minus a square minus 4ay upon 2. And what is the upper limit? See, it intersect the domain, the bounding curve over here also, right? So you have to write the equation of this curve in this format, x as an explicit function of x and y. So what is the equation of this curve? The equation of this curve is y equal to x square by a. Equation of this curve is y equal to x square by a. So I'll put it in this format, x as an explicit function of y. So we get it, x equals to plus minus root ay. Why two values? Because you find this curve, this arrow intersect this curve over here and over here. So this is x equal to minus root ay, this equal to x equal to plus root ay. So I'll put it here, x equals to plus root ay, because this point lies on the right of y-axis. Now in order to get the limit of y, you see, from what value of y to which value of y, I'll move this arrow so that I get the whole domain of integration. So I'll have to move it from y equal to 0 to y equal to a by 4. So y equal to 0 to y equals to a by 4. See, whenever you write the limit, you need not write this x equals and x equal and y equal and y equal. You just write a by 2 minus a square minus 4ay upon 2 to root ay, y equal to 0 to y equal to 4. So I can simply write it as this. After changing the order, the limit comes out to be a by 2 minus a square upon minus 4ay upon 2 ay, and this is 0 to a by 4. This is not 4, this is a by 4. A by 4. So this is, after changing order, this is your integral. This is your integral, right? Sometimes this may be a question and it will be asked to change the order of this integration. So our question, this is the answer, and if I make it a question, then our question will be the answer, right? Suppose I want to change the order. First I have to plot the domain of integration. Domain of integration will be bounded by y x equals to a by 2 minus a square minus 4ay upon 2 and x equal to root ay, y equal to 0 and y equal to a 4. I'll get the same domain. See, in both the order, domain of integration is a common thing. Domain of integration is same for this integral and the integral given in the question. So whenever you are asked to change the order, first thing you do is you get the bounding curves, plot these curves, get the domain of integration, and from the domain of integration you can get the limit in any order. You can get the limit from this domain for this integral, you can get the limit for the integral given in the question from this domain of integration. So main thing, the most important thing, you have to plot the domain of integration, right? BIOTECH